So in this video we will talk about some questions based on structure, hybridization, and charges. Okay. So the first question is, which of these is an acceptable Lewis structure for diazomethane? This is the name of the compound, diazomethane, if it has carbon, nitrogen, nitrogen double bonds. So for the first one, if you look at it, this nitrogen obviously catches your eye because it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. That's not acceptable, so that's not the right structure. For this structure, you have carbon with 3 bonds and 1 lone pair. It gets a negative charge, all fine, 8 electrons here. This nitrogen has 1 bond here. This is a triple bond, so 3 of these bonds will have 6 electrons plus 2 here, 8. That is fine. Nitrogen with 4 bonds is going to have positive charge. That is also fine. This nitrogen has 3 bonds and a lone pair. That also has 8 electrons, no charge. So this structure seems fine. On this structure, nitrogen has 4 bonds, but it does not have a positive charge, which it usually should have. Therefore, this structure is not correct. And on this structure, you can see this one catches the eye right away. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 electrons. Again, you cannot have excess of an octet for the second period elements. Therefore, this is the only structure that is going to be appropriate. So for this question, they ask you how many resonance forms can you write when you delocalize the electron, the single electron radical here. So delocalization obviously needs to have pi system so that you can conjugate either the positive or negative charge or the unpaired electron. So here there is no double bond here, therefore you can write only one structure, which is just this one, or you can write 0 delocalized structure, or you can have only one structure. Okay, both are correct to say. Here again you can see that this is possibly conjugated, but as I have mentioned in the classroom, if you break these electrons, okay, with fishhook arrows, then you might be tempted to write a structure that looks like this. Single electron goes there, this pi bond is still intact. That's the double bond. So this is a cumulative double bond. Cumulative double bonds can exist only in linear, okay, structures. This bent structure is not going to make this possible. Therefore, you can write only one structure here, or 0 conjugated structures. Okay, so here this can conjugate, so you can write a structure that looks like this. Okay, and that is now going to give you a resonance form that looks like this. Okay, and you can write 2 more from here. So you can write 3 conjugated structures, and at least, like, including this, you have a total of 4 structures. All right, so that is possible. So therefore, between these 3, this is the highest so far. But obviously, since this can conjugate on both sides, you can write resonance form from this benzene ring, resonance form from this benzene ring, and therefore this one is going to have the highest number of delocalized resonance forms. Okay, so the next question asks you about a Lewis structure where the sulfur atom is going to have a formal positive charge. Which of these structures will have sulfur atom with a formal positive charge? So you have to go back to your periodic table to see how many electrons each of these elements will come with as a neutral element. So obviously oxygen is in group 6A, which means oxygen is going to have 6 electrons as an element, right, with 2 unpaired electrons, 2 lone pairs. That's what oxygen is. Sulfur is right below oxygen, so same story for sulfur. Sulfur is going to have 6 electrons as an element. Now when it's bound, if it loses electron, then it is going to have positive charge. If it gains electron, it has to have a negative charge. So if you look at these structures here, sulfur, for example, here has 1, so that's electron that belongs to sulfur. 2, 3, 4, 5, 6. So if you break the bonds and let sulfur have its electrons, then sulfur here is going to have 6 electrons. Therefore, it will have a formal charge of 0. If you look at this structure, sulfur is going to have 1, 2, 3, 4, 5. So sulfur, when you break the bonds and give the electrons back to sulfur, sulfur will be able to get only 5 electrons back here, right? Therefore, this will have a formal charge of +1. Okay. If you look at oxygen, oxygen has 1, 2, 3, 4, 5, 6, 7 electrons. So here oxygen is going to have -1, sulfur is going to have +1. So if you look at all the other structures, these things will check out. So this is the only structure where sulfur will have a formal charge of +1, and that's how we count the formal charges, right? If we have a sulfur, for example, last structure, right? You have CH3 here, Cl on this side. So if you break the bonds and give sulfur its electrons back, then sulfur will be having 1, 2, 3, 4, 5, 6. It will get 6 electrons back. Therefore, it is still going to be chargeless. Okay, so that's how you look at the formal charges. Okay, which resonance structure contributes the most to the overall picture of this molecule? So that basically depends upon whether the charges are correctly placed, and if the electrons, all the atoms that needs to have an octet has an octet, and also if the electronegative atom gets electrons compared to an less electronegative atom, and so on and so forth. Okay, so if you look at structure A, you see carbon here does not have an octet. It has 1, 2, 3, 4, 5, 6 electrons only. Therefore, this has lesser preference as a resonance form for the molecule to assume, right? That's one way to look at it. Again, here carbon here does not have an octet because it has only 3 bonds and a positive charge. Here, if you look at this, oxygen has an octet, carbon has an octet. This is a triple bond, right? It's not clear here, but I'm sure, like, if you have this question in the exam, it will be clear for you that it's a triple bond. So carbon here has an octet, oxygen has an octet, nitrogen has 4 bonds. Even though it's a positive charge, it is still an octet. So this structure seems fine. Oxygen here has an octet but a positive charge. Carbon has an octet. Nitrogen has an octet, 1, 2, 3, 4, 5, 6, 7, 8. And carbon has, obviously this carbon is going to have an octet because it has 3 sigma bonds with hydrogen and 1 sigma bond with the nitrogen. So this is also a structure that has octet on all the carbon atoms. But if you look at it, this one seems more favorable, right? As you can see, because you have oxygen with a negative charge, nitrogen with a positive charge, as opposed to here where oxygen has a positive charge, nitrogen has a negative charge, because oxygen is more electronegative than nitrogen, right? Oxygen's electronegativity is higher than nitrogen. Therefore, oxygen having a negative charge, nitrogen having a positive charge is going to be more favorable than the other way around. So that's why this is the right answer. So this question asks you, what is the hybridization of the orbital containing the unshared pair of electrons on the nitrogen atom in pyridine? So this is a question, this is a molecule we have seen, pyridine. It's a pretty good base, not a strong base, but it's a useful base. Okay, and so the nitrogen here is sp2 hybridized because it has a double bond, right? So when nitrogen is sp2 hybridized, that means these electrons that is part of the sigma bond here, these electrons that is part of the sigma bond and the lone pair, they're all going to be sp2 hybridized. These electrons on the pi bond though, right, that is going to be pure p orbital. Okay, those electrons are going to be the p orbital. So the lone pair are going to be in sp2 hybridized orbital. So that is the answer for that question. Which of these substructures have, or these structures have 8 pi electrons? Okay, so these electrons are going to be conjugated, right? These electrons are going to be conjugated. So these electrons are part of the pi structure. By the way, if you look at this electron, these electrons are not going to be conjugated, right? Because they are perpendicular to the p orbital that is needed. So these electrons are not going to be conjugated, whereas these electrons are going to be conjugated. So these electrons move in, this goes out, right? Similarly, you can also write a resonance form where these electrons move in and these electrons can move out. So these electrons on the nitrogen at the bottom and these electrons on the nitrogen at the top, they are both conjugated. Therefore, this will have 8 pi electrons. Okay, these electrons are going to be conjugated, whereas these ones, they are not going to be conjugated, just like these are not going to be conjugated. Okay, therefore this has 6 pi electrons. On this sulfur also, one lone pair will be conjugated, the other will not be conjugated. Okay, this also has 6 pi electrons. So one only is the right answer for this question.